Hey, what's up guys, welcome back to another video, and in this video we're going to be going over the 2025 GCSE Computer Science predicted paper. Hopefully you guys are well. I haven't forgotten about you. I'm sorry, being in third year of uni isn't really easy, and trust me, I haven't forgotten about you. Before we go through the paper, as usual, if you like this video, if you find this useful, make sure you like, comment and subscribe. It helps me out and it helps tons of other computer science students just like you out as well, so make sure you do that. And just a disclaimer, these are questions that I think that may come up. It might not. Obviously, the previous year's paper is still there. I highly encourage you to do that first, because again, that's an unseen paper. You're not going to have done that before, although maybe you've done some questions before. Only attempt this paper if you think you've done 100% of the revision and you're ready to see how you do in the actual exam, because this is going to be very similar to the exam experience. So make sure you do it in exam condition. Give yourself 1 hour 30 minutes, set a timer and attempt this paper in time conditions. If there's any mistakes, again, they'll be in the description or it'll be pinned in the comment section, because obviously I'm doing all of this live. Also, I know other specs also saying AQA, can you do that? Can you do Edexcel? It's only me currently doing all of this. So if this does become a big thing, then 100% I would love to do a predicted paper for AQA, Edexcel, even A level. But at this point, GCSE OCR, you guys are lucky. So make sure you take this. I want to see every single one of you with a grade 9 at the end of this. Alright. Enough of the app, let's begin the predicted paper. Alright, so 1 hour 30 minutes. Now, the first question is a standard table with 8-bit binary to hexadecimal. This should be able to do in your dreams. So how you do this is you split this number into nibbles, and the first part you get 1, 2, 4, 8. 8 plus 2 is 10. 10 in hexadecimal is A, all the way until F, which is 15, and the first part is 2 plus 4 plus 8, which is 14, so EA to the game. 40, you do the same thing, so the right side is going to be 0, 0, 0, because that's 0, which is just 0, 0, 0, 1, 0, 0, like so. Again, same thing here, split it, so you get 1, 2, 4 on the right, and 1 plus 8, which is 9, 94, and 3D, so the right half, or the left half, is going to be 3, which is 0, 0, 1, 1, and the right side is going to be 1, 1, 0, 1. It's going to be 13, like so. Hopefully you were able to get this correct. Easy 4 marks. Now we have an interesting question. Okay, part B. A student opens a text file. It contains 40 characters as shown here and is represented using ASCII character set. What is meant by character set? Character set is a range of numbers, letters, symbols that can be represented by a computer, each character having its own binary value, which we'll see eventually here in part 2, which says character G is this binary number here. So for this question, there's 2 ways around doing this, but let's look at the normal way, which is this binary number. Let's try and find what this is. And after doing some quick maths, 1 plus 2 plus 4 plus 64 is 71. Then we gotta just work backwards. So if G is 71, we get F, which is 70, and etc. until C, which is 67. That to be this binary number. Alternatively, you could have remembered that capital A is 65, which is maybe something you know from revision, and you can just work your ways to the top. So C, which is 67. Hopefully that makes sense. Now part 3, calculate the size of the text file in kilobytes. Again, this is one of those questions that haven't come up before, and it might be the first year it comes up. So file size is equal to number of bits per character times number of characters. Number of characters is 40, so we get 40 multiplied by bits per character, which is 8 because it's ASCII, which gives us a value of 320 bits, but you also need to remember that 8 bits equals 1 byte, because again we're trying to convert it into kilobyte. Alternatively, this 8, we could have just done it by 1 and just get that as 40 bytes. Then we need to remember that to go from bytes to kilobytes, we have to divide by 1000, because we're going smaller. So we do 40 divided by 1000, which gives us a value of 0.04 KB. Now the main part is obviously remembering this formula. So yeah, cool. Let's move on to the next one. Typical question. Give 2 reasons why a programmer would prefer to use hexadecimal to represent numbers instead of binary. Now, the first one should be easy. Hexadecimal values are easier to work with than binary because it's more easily understandable by humans. And the second thing we can say is hexadecimal values are shorter than binary if you're a G. We could have also said hexadecimal values are easily converted, or hexadecimal values are less susceptible to errors due to the nature of having the letters instead of numbers. Alright, part D. Binary shifts can be used for multiplication and division. Draw one line from each shift on the left to its correct outcome on the right. So the first one, right shift of 2 places on this number. So right shift means we're going right, therefore we're cutting off the last 2 and essentially padding the top with 2. So 0, 0, 0, 0 is what we're going to start off with, and that is only the last one. Apologies for the bent line. Left shift of 2 places on this number. So we're going left, we're cutting off the front 2 zeros and we're adding 2 zeros to the back. 1, 1, 0, 0, which is this one here. Right shift of 4 places on this. Now, technically, if you read ahead, this should be as simple as that, and this should go here. Because again, each time you go to the right, you're dividing by 2. So if you divide by 2, divide by 2, divide by 2, divide by 2, 2 to the power of 4, which is 16. Yeah, cool. Alright, here's the next question. A graphics designer is using the computers to perform various tasks. Complete the table by identifying the most appropriate protocol for each of these. So if you don't know your protocols, again, you can find detailed note, not detailed, but concise notes on the website alongside the past videos, and I've definitely made a video on this. So uploading a high resolution image to the cloud server, where we're transferring a file from the client to the server, which is FTP, which is a file transfer protocol. Viewing their online portfolio on a web browser. HTTP, which define how web browsers work, or you could have HTTPS. Either of those should be fine. Sending a large file to a print service, assuming the print service is on the server, then we're transferring files. Whenever files are involved, we're doing FTP. Receiving an email from a client. Now, this could be either POP, which is Post Office Protocol, or IMAP. And the difference between these is POP downloads the email, IMAP, you just retrieve it, you don't download it. So either of those should be fine. Now part B, what is meant by a network protocol? This should be on top of your tongues. A protocol is a set of rules for communication, as simple as without these rules, people would be communicating in different, not people, devices would be communicating in different things, which would mean that Sony headphones don't work with your iPhone, for example. Now, part C, some protocols have layers. What is an advantage of using layers? Pretty standard question that you should have memorized or learnt by doing all of these past papers. Self-contained. This means one layer can be developed or changed without affecting other layers. This is a new question actually, because there's not actually been a Bluetooth question before, and surprisingly, 2025 might be the first year that we get a Bluetooth question. The graphics designer also uses Bluetooth to connect a wireless keyboard and mouse to the computer. Describe one disadvantage of using Bluetooth technology. Now, you can apply a day-to-day life example of Bluetooth, whereby if you go further away, it kind of disconnects. So that's one of the disadvantages. So Bluetooth has a short range. If the keyboard or mouse is too far from the computer, or there's obstacles like a wall, etc., the connection may become weak or even drop. That's a disadvantage, you can say. Again, if you have other points, any other queries, drop it down below. Hopefully other students, you guys can help each other out. I'll also look. Alright, question 3. 2 educational institutions are deciding which network model would suit their campuses. Institution A, this much. So clearly, Institution A has a lot of staff, a lot of students, a typical school, which also has an IT department. So typical school has a client server. Now, if we have 50 students and staff and no IT department, it's more obvious to have a peer-to-peer. Now, we're asked to justify this, and what we can say is basically what we said. That Institution B has only 50 users and no dedicated IT staff, so peer-to-peer would be appropriate because it's simpler to set up and does not require specialist staff to manage the servers. Institution A has 1500 users and a dedicated IT department, making it suitable for client server. That's something that I would say. Part C, students in both institutions use and can access the internet and the World Wide Web. Explain the difference between internet and www. Again, this is one of them that you should have flashcards, or again, the website has flashcards, which you could use and also make your own. The internet is the infrastructure, which is a collection of networks, and www is the actual web pages that are stored on the servers. Make sure you get this correct. Now, part D is a network hardware question. Explain the role of an NIC on a campus network and discuss why both institutions A and B would need NICs regardless of the model they choose. Again, NICs help you connect to the internet. Without NICs, you're not going to be able to connect to that network. So it doesn't matter what network model you have, the devices are going to need the network interface card. So that's basically what we're going to say. Now, part E, a student from institution A says, star networks are the same as client-server networks. On paper, these two seem the same, but they're not. Let me tell you why. Star networks, or that's a topology. What a topology is it describes how devices are physically connected. A network model, on the other hand, describes how the data and resources are shared on a network. So in client-server, you got the server and you got clients and they're sharing resources from the server. In star, you got the physical layout, which is you got something in the middle and you got different devices connected. So that's what we would say. A network topology describes how devices are physically connected. A model describes how data and resources are managed, not the same. So a star topology can be used in a client-server network. Because as long as you got a server, each client, maybe a client could be in its own little star topology. So you can use them interchangeably. But it can also be in other types of networks like peer-to-peer. So hopefully that is understandable. Alright, F, institution B has a higher network performance than institution A. Explain how each of these following can contribute to the performance of a network. So Wi-Fi frequency, so there's two types. 5 GHz and 2.4. So 5 GHz can carry more data, but it does not have enough range. So 5 GHz frequency can carry more data per second than 2.4. That can also contribute. Objects can also interfere and block the signal, and the number of users. Bandwidth is like the maximum capacity of a wired or wireless network. So imagine you have a bandwidth of 10 and you've got 10 users, it gets shared equally. So each person would get in turn 1 megabytes per second or something like that. So make sure you know all of these things that affect network performance. Now, question 4 is your typical 8 marker. Last year's one was actually surprising. I mean, my original predicted paper did not have one, and actually, I mean, you can say whatever, but it wasn't this type of question. It was an open source and closed source question, so I don't want to hear it. But this time, I'm saying that we'll get a normal question, hopefully. Sarah is an architect working on designing a series of new sustainable buildings. She has teams of hundreds of people creating models, conducting environmental impact assessments, and drafting blueprints. Okay. Recent developments in building information modeling, BIM, software mean that a computer program can perform the tasks of dozens of her team members in a much shorter time, a bit like the new AI wave. Sarah decides to increase her use of BIM. So before starting, I always like to do a bit of a mind map or plan out the answer. Job displacement is something you can say. Technically it's cultural, but it depends how you talk about it. So we're going to talk about it as in the current workers. It might mean there's reduced hours and unemployment. And for legal issues, we can talk about the IP rights behind the models created by the BIM software. And from a cultural standpoint, there's going to be a shift from like these jobs. Once these used to be a job, now the software's doing it, and it's going to take time to obviously adapt, and individuals may devalue their hard work, maybe learning these type of skills, because now just the software can do it. So that's also a cultural issue we can talk about. So I'm going to paste in my model solution. So I recommend doing 3 paragraphs, 1 for ethical, 1 for legal, and 1 for culture, and maybe even an introduction, but that's up to you and up to your time. Increasing the use of BIM software in the architecture firm introduces several issues. From an ethical standpoint, the shift to BIM software could result in job displacement, as software automate tasks traditionally performed by humans, potentially leading to unemployment or reduced hours for work. work. This raises concerns about the fair treatment of employees and whether workers will be adequately retrained for new roles, because obviously it's not ethical, is it, that a software takes over your perhaps a role that you took so long to actually learn about. Regarding legal issues, that's what's right and wrong. So the firm must address concerns over the IP rights, especially regarding the ownership of designs created by this software. There is also the matter of liability for errors. For example, if the software makes a mistake, it's also unclear who is responsible for the problem. Is it the software developer, is it the architecture, or is it the company? Additionally, BIM software must ensure that designs meet legal standards, including building codes and environmental regulation. Finally, from a cultural perspective, the shift towards automation might reduce the level of human interaction in this design process, potentially impacting the collaborative nature of the architecture. Because obviously architectures, people collaborate, different people working in different sectors might come into the office and discuss what they've learnt. For example, it says in the question that there's different people doing certain things. Now, employees might also resist the transitions if they think that the skills are being devalued, potentially harming the morale of workplaces. There's also the challenge of adapting to these technological changes, which may not be well received by all team members, particularly those that might not to be like offensive or anything, but towards older people that might have like they want things the old traditional conservative way, because maybe they've gone to university and learnt the original way and now a software can do the same, so then they're not going to be happy about it. So that's what we mean by cultural perspectives, and this is how I would model this question. Alright, on to question 5. A computer system faces various security threats, so we need to complete this table. The first task is attempts to guess passwords repeatedly until the correct one is found. That's brute force. Spyware, as the name suggests, is someone spying, so logs activities and keystrokes and sends it back to the criminal. Injects malicious code into a database query to manipulate or access information. That is SQL injection. What that is, it's when you have an input field, you would write some SQL and it would go into the database and change or delete things, which is bad. That's where input validation and sanitation come into play. Data interception, as the name suggests, is when someone steals the data being transmitted. So unauthorized users attempt to access or steal data while it's being transmitted. This is a way to prevent this would be to encrypt your data. That's why we use encryption. What is meant by the term firewall? Scans the incoming and outgoing traffic and may even block it in certain instances. So there's a criteria. It checks if these are allowed or if it's not allowed, and it monitors. Alright, part C. While managing the system, the IT team notices that the computer's hard drive is running slower than usual. They suspect that the hard disk has become fragmented. Describe how defragmentation software could overcome the issue of slow computer system. So, defragmentation software reorganizes the files and all free spaces together and all parts of the same file together. As a result, fewer disk accesses are needed. So, when you have a hard drive, I don't know if you've seen this picture before or not, but imagine that's your file 1 and that's your file 2 and this is a hard drive. What happens is when you delete stuff, you get these empty spaces which don't really need accessing, a bit like an array. So what happens is this part here becomes more closer to this. All empty spaces are collated together. So when you're indexing this hard drive, it's easier to find things that you want. Again, hopefully that makes sense. Alright, question 6. Jake wants to buy a new computer, but he does not understand what the different parts of the computer do. Jake has heard of a CPU but isn't clear on what it does. No worries, we will explain to him how it works. The CPU stands for the Central Processing Unit. It is a part of the computer that fetches and executes the instructions that are stored in main memory or the RAM, and the CPU also contains the ALU, which is arithmetic logic unit. Nice and straightforward. Again, this should be 4 marks. Not sure what happened there. That means it's out of 81. But anyways, part B. One computer has 64 kilobytes of cache and the other has 512 kilobytes of cache. Explain how the cache size can affect the performance of the CPU. So what cache is it stores frequently used instructions and is faster to access than going back all the way into RAM. You could think of it as onboard storage on CPU. Therefore, having more cache improves the performance of the CPU. Now you might think, well, why don't we just have gigabytes and terabytes of cache if it's going to make it fast? But if you actually think about it, if there's something that you're getting frequently and it's getting stored in the cache, it's getting fuller, and in turn it's just going to be hard to find that frequently accessed item. So hence why we don't have gigabytes and terabytes of cache, at least not as of now. Correct me if I'm wrong. Alright, part C. Each computer has a BIOS. Tick one box to identify which is true or false. BIOS stands for boot input output standard. Again, a trick question, but it's false. It should be basic input output. The BIOS can be used to alter hardware settings such as which storage device a computer boots from. That's true. And BIOS settings are stored in the RAM. Again, trick question. It should be ROM, read-only memory. Yeah, it should be basic input output system, not standard. So Jake thinks that his smartphone is an embedded system. Is he correct or incorrect? Well, incorrect should be the answer because a smartphone can do everything. It's a multifunctional generalized or general purpose computer basically, and not a specific function. An example of an embedded system would be something like a microwave or a washing machine that does just one particular item. Alright, virtual memory. Tick one box to identify the statement which is true. So a section of primary storage is partitioned to act as virtual memory. That's incorrect. It's not primary, it's secondary. Now, virtual memory is needed when RAM is full or nearly full. That's true, and that's it. But let's look at the rest. Data from VM is transferred back to secondary storage when needed. Makes no sense. VM is in the secondary storage, so why is it getting transferred back? That should be primary, and data from ROM is transferred into VM. Not ROM, but RAM. Alright, question 7, I think it's the last one. A radio station uses a digital camera to take photograph of a computer scientist for their website. The photograph is stored as a bitmap image. Describe how bitmap images are represented in binary. An image is made up of a series of pixels. Each pixel is a specified color, which is in binary. So perhaps with an example, in a black and white image, perhaps 0 is black and 1 is white. That's how it would be represented, and more bits allow for more color detail. My question to you is, how many colors can you represent with 3-bit? That should be simple. It's 2 to the power of 3, which is 8. And the reason why is actually 000 can be represented as one color, and all the different combinations of this can be a different color. So anytime you're given a question on that, that's how you answer it. Alright, part B. Identify 3 pieces of metadata that would be stored in an image. Metadata is just extra information that provides more information about the picture. So like data about the data. So in images, we might have the color depth, which again, what we talked about previously, like how many bits are used for representing colors. We might also have date created or date modified, etc. And we might also have geographical data, like where it was taken and the specific coordinates of the map, etc. Alright, part C. The camera that they're using allows users to view and edit photos immediately after taking them. Give 2 examples of data that the camera could store in RAM. Now there's plenty of things that you can write down for this. The first one being the most obvious, which is it holds the image temporarily, because RAM is used to store working data. And the second thing is to temporarily hold the editing data, such as the brightness adjustments, the cropping information, etc. Now part D, describe what type of secondary storage the camera is likely to have and justify the reason behind this choice. So this would be flash memory due to it having no moving parts, and make sure you apply it to the question. And so it's resistant to damage from drops or movements, as you know. Also, you could have had other things such as it has faster read and write speeds, and it's also compact, lightweight, making it ideal for camera. Alright, part E, last two questions actually. The station's web developer Alex decides to upload an image from his computer. Before uploading the image to the website, Alex considers compressing the file. Explain why image compression might be necessary in this situation. So if you don't know what compression means, that is making something smaller whilst also retaining the information, some of the information, it depends. But if you have got a lot of information and you're trying to go onto a website, it's going to take time to load. Compression helps to make it smaller and so that it loads faster. So we can say compressed images load faster on the website, leading to a better user experience. And also you can mention something about smaller image sizes take up less space, and you could have also had something along the lines of part F, identify the most suitable type of compression for the image file. Justifying the answer. Well, there is only one answer, which is lossy compression, because images you can get away with this because the slight loss of quality is often not noticeable to the human eye. Now, if you try to apply lossy on text, that's going to be an issue because we won't be able to read what the letters say. So yeah, make sure you know this. And that's the end. So let me know how you guys did in the comment section down below. If you want to see a paper 2 prediction, like, comment and subscribe, and I'll see you in the next one.